Hello class, before we begin on today's lesson, let's review the previous lesson. Can anyone stand up and repeat for the class what interaction is and under what conditions does a magnetic field appear? Zoom please.
Teachers, the interaction between the magnet and the magnet, the current and magnet with current is called the magnetic interaction.
That is correct. As shown in the diagram, we know from this experiment that when an electric current flows in opposite directions through two metal rods, the rods will push each other apart. That's the magnetic force, right? So, can anyone help me come up with ways to determine the magnetic force and its magnitude?
Teachers, I don't know.
That is a tough question, is it? To determine the direction and orientation of the magnetic force, let's move on to today's lesson. Magnetic force. To investigate the direction, orientation, and magnitude of the magnetic force, I will introduce the following experimental setup to the class. Since we can't borrow the experimental setup to carry out the experiment, I will show a video as a substitute. Please watch the video from 4:35 to 4:45 and complete worksheet 1 within 8 minutes. Okay, time's up. Now I would like to invite a representative. After conducting the experiment, I kept the magnetic field strength be constant, then gradually changed the values of the current intensity, the length of the conductor, and the angle between B and I. Here's the data table. Based on the data table, we can see that the ratio between F over L times sine alpha remains constant when the magnetic field intensity is unchanged. This is the magnitude of the magnetic field B. Next, the groups will have 7 minutes to complete worksheet number 2. Okay. Therefore, we can conclude that the unit of the magnetic field B here is
and the sin alpha will help you this, so you can see that the B is the unit.
so the magnetic direction perpendicular to the wire and the magnetic field force. Now I will introduce you to the left hand rule.
This is also
So the left hand rule is demonstrated as the vector B will go perpendicular and straight into our palm. The current I will go with the direction from our wrist to the fingers, and the magnetic force F will go along with the direction 90 degrees of the palm. Okay. So next, let's move on to the next part, measuring the magnitude of the magnetic field B. Now I will divide our class into 4 groups. Each group will have 7 minutes to answer 3 questions. And here are the 3 questions. with question number 1, can you say the function of each one?
After discussing, we need to conclude that the function of the magnetic induction B is equal to F divided by I L sigma alpha. Yes.
Okay. So next up is question 2. Which parameters need to be measured?
Here we have to measure F and L, which here F is the magnetic force applied on the current carrying wire.
Okay.
I here is current amplitude, and the L here is the length of the wire. Alpha here is the angle between the B and I.
So finally, to the question, the third question, can you propose a measurement method for B?
We apply the function to measure the FIL to measure B, and if the factor that causes error, I think that's alpha, the angle between B and I, which called